Hi dear students, we are going to discuss alkalinity of a water sample and in that we are going to find alkalinity of water sample. Means simply what kind of alkalinity is present in the water sample, that types we are going to find, and once we get idea about types of alkalinities we are going to find amount of alkalinities. So first of all, who responsible to make water alkaline? As we know that three types of solutions are there: acidic, basic and neutral. Then what about alkaline solution? So keep in mind the base which is a soluble in solvent, the base which is a soluble in solvent, that base called as a alkali and produced solution known as a alkaline solution. So here the base which is not soluble in solvent, that will remain a base, it will not become alkali. So here we can conclude that all alkalis are bases. All alkalis are bases, but all bases are not alkalis, because all bases are not soluble in solvent. So here some examples of alkalinities we are going to see. So in that, first one is the hydroxides, then bicarbonates and carbonates. So hydroxides like NH4OH, calcium hydroxide, carbonates like magnesium carbonate, iron carbonate. So here calcium carbonate will not come, as we know it is a practically insoluble in water. And in bicarbonates you can see calcium bicarbonate, magnesium bicarbonate, iron bicarbonate. So as far as strength of basicity is concerned, which one is a stronger base? So here hydroxides, that is the OH minus, are stronger than carbonates. Carbonates, that is the CO3 2 minus, and carbonates are more stronger than bicarbonates. So hydroxides strength greater than carbonates, carbonates strength greater than bicarbonates. So as far as reactivity toward acid is concerned, which one will react first with the acid? Needless to say, as per their strength, the base or the alkali which is a more stronger, that react with acid first. So hydroxide react with acid first, after that carbonates, and after that bicarbonates. So here we will see the theory behind the determination of alkalinity of water sample. As in engineering chemistry, second practical is there on the determination of alkalinity of water sample. So here water sample containing, for example, three kinds of alkalinities: hydroxides, carbonates and bicarbonates. So in that, what we are adding? We are adding acid. Okay, so acid we are adding from a burette. Okay, an alkaline water sample present in conical. So before to start titration, we have to use first indicator, and that first indicator is a phenolphthalein indicator. So here, if we add phenolphthalein indicator in the alkaline water sample, we will get a pink colored solution. And then in pink colored solution, we have to add acid. So the time when we add acid, as I said, who will react first with acid out of three alkalinities? OH minus first react with HCl. So OH minus react with H plus and it produces H2O. So that is the first reaction. You can say complete neutralization of OH minus. After complete neutralization of OH minus, second base, or you can say alkali, start reacting with acid, and that second alkali is carbonate. So second reaction, CO3 2 minus plus H plus, it produces HCO3 minus. Means carbonates convert into bicarbonates. So added acid having a 1 plus on hydrogen, that is what H plus, but alkali having a CO3 2 minus, that is a 2 minus. So 1 plus cancel 1 minus out of 2. So 2 minus changes to 1 minus. So here we get a bicarbonate. So this is what the first step, in that OH minus getting completely neutralized and CO3 2 minus getting half neutralized. I am saying half neutralization. Why? Because 2 minus changes to 1 minus. That's why half. So that time pH of solution decreases to 8.7. Right? Decreases means pH value decreases down, because we are reacting alkalis with acid, and in a neutralization reaction basicity decreases down. So if basicity decreases down, then pH also decreases. Okay, so we get pH around 8.7, and the time when these two reaction complete, we get a colorless solution. So initial color is pink, and that pink color changes to colorless. Right, once we get colorless, we have to stop addition of acid from the burette. Now in second part, remaining 50% CO3 2 minus. Right, because in first step carbonates gets half neutralized, so remaining half, that is what the bicarbonate left behind in the solution. Right, so that will neutralize in the second step by using a methyl orange indicator. So if we add methyl orange indicator in the colorless sample, you will get a yellow color, and then you have to start the addition of acid till yellow color changes to orange. So here in this step, bicarbonate, you can see the reaction, bicarbonate, that is HCO3 minus, react with H plus, and it produces H2O plus CO2. H2O plus CO2, that is a complete neutralization, and pH again decreases down to 4. 4, that is a completely acidic solution. Right, because all alkalis completely neutralized, so no basic or alkaline component in water sample. Right, only acid is there. That's why pH of solution decreases to 4. So as far as reactions are concerned, as we seen already, that first reaction of H plus with strong base, that is the OH minus, first reaction complete neutralization. Then in second, carbonate react with H plus, it gets half neutralized and we get a bicarbonate. So for first two reactions we used P means phenolphthalein indicator, and in third reaction, that is the second step of the titration, bicarbonate react with H plus and it produces H2O. Okay, and for third reaction we are using methyl orange indicator. So two indicators we use for these reactions. First indicator, right, for first two reaction, and third indicator, second indicator for third reaction. Now as far as procedure is concerned, we have to carry out procedure in two parts. First part, why two parts? Because we are having two indicators. So in part 1 we are using a phenolphthalein indicator. So you can say part 1 is a phenolphthalein end point. Here I am just going to explain the procedure that we are going to carry out for performing the practical. Right, as I said that this point as it is there in the second practical. So what we are taking in the burette? We are taking acid in the burette. So you can take HCl or you can take H2SO4. Then you have to pipette out water sample, right? Pipette out, or you can take a measuring cylinder to measure the sample of water. So here you can take 10 ml, 25 ml, 50 ml, 100 ml water sample in the conical, and in that we have to add phenolphthalein indicator, that is 1 to 2 drops of phenolphthalein indicator. So two things are clear. In burette we are taking acid, and in conical we are taking a water sample and we are adding indicator in it. So here conical contain water sample and indicator, and color become pink, and we have to start the titration till pink color changes to colorless. Once we get colorless solution, we have to stop the addition of acid, and we have to note the burette reading as V1 ml. Okay, so once we get V1 ml reading, we have to proceed toward part 2. But before proceeding toward part 2, things need to remember. Do not throw the solution and do not refill the burette. Means in part 1, pink color changes to colorless. So that colorless solution you are not supposed going to throw. Keep that solution as it is. And second thing, do not refill the burette again. Means in part 1 you got V1 ml burette reading. So we have to wait at V1 ml only. You are not supposed going to refill that burette again for adjusting 0. No need. Alright. So V1 ml is what? V1 ml is equivalent to complete neutralization of OH minus and half neutralization of CO3 2 minus. Then part 2 is methyl orange endpoint, that is the second indicator we use. So for part 2 what we have to do? We have to take solution from part 1. Which solution? Colorless solution. And in that we have to add 1 to 2 drops of methyl orange indicator. So in colorless sample, add directly methyl orange indicator. You will get a yellow colored solution, and you have to continue addition of acid from the burette. I used word continue the addition of acid from the burette. It means you are going to start addition of acid from the burette from V1 value of burette reading that you got in part 1, not from 0, till that yellow color changes to orange or red. Okay, and once that yellow color changes to orange or red, stop the addition of acid and note the burette reading as V2 ml. So in part 1, V1 was the reading, and in part 2, V2 is the reading. Alright, so here endpoint indicate what? Complete neutralization of bicarbonate, right? And V2 ml is equivalent to what? Is equivalent to complete neutralization of water sample. Means water sample gets completely neutralized. No alkali left behind after completion of part 2. Okay. So as far as calculations are concerned, as we know that we use two indicators. First is a phenolphthalein, that is a P, and second one M, that is a methyl orange indicator. So burette reading, initially burette having acid, and that we adjusted up to 0. Alright, after phenolphthalein endpoint, we got a V1 ml burette reading, that is a 0 changes to V1, and after methyl orange endpoint, V1 changes to V2. So here we got a V1 by using a phenolphthalein indicator, and we got a V2 by using a methyl orange indicator. So in formulae you have to take same things. So phenolphthalein P and methyl orange M. So we got a V1 by using a P and we got a V2 by using a M. So P is equal to V1 and M is equal to V2. Remaining things are same in both the cases. That is what Z. Z is the normality of acid multiplied by 50. 50 is the equivalent weight of CaCO3. 1000, that is the volume of solution, right? 1 liter, 1000 divided by V. V is the volume of water sample. Okay. So if you see these two formulae, only one change is there. In P, that is the phenolphthalein, V1 is there, and in M, methyl orange, V2 is there. Z 50, 1000 and divided by V, these things are the common in both the formulae. Okay, so V1, V2, as I said, burette reading, Z normality, and V is the volume of water sample. So these two formulae you are going to use to find the value of P and M. So once you get value of P and M, right, you can find out types of alkalinities. But for finding types of alkalinities, you compulsory required values of P and M. So what kind of alkalinities combinations are possible in water sample? So first, only single type of ion may be present in the water sample. You can say that yes, this sample having only OH minus, or you can say yes, this is the second sample and that having only carbonate. This is the third sample and that having only bicarbonate. So first possibility, that is the presence of only one, or you can say single ion. Second possibility, any two ions. In that first possibility, OH minus and CO3 2 minus, that is hydroxide and carbonate, both present together in the water sample. Second possibility, carbonate and bicarbonate. And third possibility, hydroxide and bicarbonate. These two alkalinities will not stay together, do not coexist. What is the reason? Why OH minus and HCO3 minus are not present together? Because OH minus is very strong and bicarbonate is very weak. So OH minus react with bicarbonate, right? And it produces carbonate. So here OH minus react with bicarbonate and they produce H2O molecule and a carbonate. So this combination is not possible because both react together. Third one, that is all three ions, that is also not possible because OH minus react with bicarbonate. So these three ions will not be there together in the water sample. Then once you get idea about types of alkalinities, from the types of alkalinities you can find amount of alkalinities. So this table you have to remember, right, if you want to solve the numerical in exam, and compulsory numerical will be there, right, on finding types and amount of alkalinities. Okay, so here in table, first sequence you have to remember, you should not disturb that sequence. And what is that sequence? So, and what is that sequence? And it is in between the P and M. You can say the relationship. So P and M, or you can say V1 and V2, because P responsible to give V1 and M responsible to give V2. That's why P and M, or you can say V1 and V2. So first relation, P is equal to 0. Second, P is equal to M. Third, P equal to half M. Fourth, P greater than half M. And fifth, P less than half M. So equal to 0, equal to half, greater than half, and less than half. That is what the relationship between P and M. Likewise, relation is there between V1 and V2. Okay, and in front of that, alkalinity in ppm. So first one is OH minus hydroxide, second one is a carbonate, and third one is a bicarbonate. So for first relation, right, it's a dash dash yum. So yum goes to last. So dash dash yum, then you have to take yum first. Yum dash dash. Dash dash yum, first relation, yum is last. Then in second relation, you have to take yum first. Yum dash dash. Then third one, dash 2p dash. So here, third relation, we are giving directly 2p to carbonate. So dash 2p dash. In fourth relation, 2p minus yum. Then interchange the position of p and yum and put it in bracket. So 2 yum minus p, and last one is dash. Then last relation, dash 2p yum minus 2p dash 2p yum minus 2p. So the place where dash is there, that dash indicate that kind of alkalinity is absent, right? And the place where yum, p, or some formulas are there, like yum minus 2p, 2p minus yum, 2 inside the bracket yum minus p, in that case that alkalinity is present, and dash means that alkalinity is absent, right? And as I said that before proceeding toward the finding amount of alkalinities, first we have to find types of alkalinities. And for finding a types of alkalinities, we have to find value of p and yum. So once you get value of p and yum, you have to see this table, and by using this table you can find the relationship between p and yum. When it is possible to find relationship between p and yum, if you know the value of p and value of yum. By comparing their values, you can find out the relationship. Once you got relationship, for example, your relationship is like value of p is equal to value of yum. Okay, value of p is equal to value of yum. Then in front of that you have to check out. So below OH minus yum is there, and below carbonate and bicarbonate dash is there. Dash indicate that two alkalinity is absent, and yum indicate OH minus present, right? So for finding amount of alkalinities, you have to take the help of the formulae, right? So value of yum is the amount of OH minus, or for example your relation is p greater than 1/2 yum, second last, p greater than 1/2 yum. Then in front of that you can see below OH minus 2p minus yum is there, below carbonate 2 yum minus p is there, and below bicarbonate dash is there. Dash indicate that alkalinity is absent. Alright. So 2p minus yum is the formula. I am talking about second last relation. 2p minus yum is the formula to find amount of alkalinity of OH minus. So in that formula, just you have to place the value of p and yum. So 2 multiplied by value of p minus value of yum. So if you do that calculation, you will get one answer, and that answer will be the amount of OH minus. So for getting idea about types of alkalinities, first you need to know amount of p and amount of yum, and just you have to compare their values with one another. You will get one relationship, and from that relationship you can find the type of alkalinity, and from the type you can find the amount of alkalinities. Okay, so this is what the determination of alkalinities of water sample. Okay, so in the next lecture we will see or we can solve the numericals of finding types as well as amount of alkalinities. So for numerical, this table is compulsory, you have to remember. And second thing, you required these formulae for calculating value of p and yum, because without finding p and yum we can't proceed. So p and yum first we have to find, then from that value we will find the relation, and from the relation we will get the types of alkalinity, and from the types of alkalinity we can find the amount of alkalinity. Hope You understood? Thank you for watching.